we want to continue trying to graph this function without plugging in any more points, without plugging in any more x values. By plugging in x values, we're actually unlikely to really figure out everything that's important about this parabola. There's stuff we're going to miss. Now, I say parabola, so I kind of let it slip, but my next statement is that the graph of a product of linear expressions is a parabola. Now, what I mean by linear expressions, well, x minus 2 is a linear expression. If you were to graph y equals x minus 2, you'd have a straight line. If you graph y equals x plus 3, you have a straight line. These are then what we call linear expressions, but now we're multiplying two of them. And we're going to see later how we could construct the graph of this thing by first constructing these two straight lines and then constructing the product that we would get from the two straight lines, but we're not going to do that just yet. Okay, the graph of a product of linear expressions is a parabola, so we're going to get a parabola, and we know what a parabola looks like. Could be this, could be over on its side. The other thing, and we're not going to quite prove this yet, but I'll assert it, that a parabola has an axis of symmetry. Now, that means there's some straight line such the parabola on one side of the line is a mirror image of the parabola on the other side. Again, we're going to defer that proof. Now, one thing that you know, though, you've already constructed a curve that could represent any parabola. If we orient the curve properly, orient it maybe up or down, or right or left, okay, this way, or down. I mentioned down, but I didn't trace it out. So there's one curve that you've already constructed, because I'm not going to show you this till we've constructed it, that can, with appropriate orientation and location and labeling of the axes, we'll see what that means, represent any parabola. So you already know what a parabola is in the sense of having constructed one using compass and straight edge. Now, you've really not constructed the full thing. You've only partially constructed it. You've constructed a bunch of points that lie on a smooth curve that we assert is a parabola and that we could easily prove is a parabola once we know what the characteristics of a parabola are. So you've constructed a parabola in at least one way. You've only partially constructed it, though, and it might well be that the full construction of the parabola is impossible. Now, you don't need to worry about that right now, because if it is impossible, it can be proven. And if it is impossible, that proof is way, way down the road, at least 6 years from now, and it takes very advanced algebra to do that. Okay, generally algebra that you would see in graduate school, not even in undergraduate school, at the post-bachelor's degree level. So we aren't going to worry about that proof. We're not going to attempt to prove that. But it's kind of interesting to know that. It might be impossible to do a full construction with compass and straight edge. Okay. Now, with all that background, the question I want to pose is now, what's the axis of symmetry for this parabola, for the parabola that we get? Asking you to accept that the graph is going to be a parabola and that a parabola does have an axis of symmetry. And you know what that means, having done the construction. So what's the axis of symmetry, though, for this parabola? It's vertical in this case. Well, you should think about that. And you really should have an idea of how to get that axis of symmetry before you go on, but now I'm going to continue, so you should pause and give that some careful thought. Well, the axis of symmetry, if it's vertical, then these 2 points here have to lie on opposite sides of that axis of symmetry, and the axis of symmetry has to be halfway between these points. So the axis of symmetry, well, halfway between these points looks like it's about here. So I'm going to draw a nice straight axis of symmetry. Didn't quite manage straight, did I? Okay, here's our axis of symmetry. And it's at equal distances from these 2 points. So these 2 points are, each point is a reflection of the other through this axis of symmetry. If the axis of symmetry was closer to one point than to the other, then it wouldn't be an axis of symmetry, would it? Because the reflection of one point would not be the other. Okay, if there's a vertical axis of symmetry, it's got to be at equal distances from these 2 points. So these 2 distances, I'll put a little line through it to indicate that they're identical. Well, what is this axis of symmetry? Well, it has an equation. The equation is x equals something, because the value of x is the same at every point on this axis of symmetry. So what is the value of x at every point on this axis of symmetry? You should think that through. Hopefully have an idea, but now we're going to go on. Halfway between these points, what's the x-coordinate? The x-coordinate, and oh goodness, see what I've done here? Now I suggest that you use the same type of reasoning we've used here. A graph y equals quantity x minus 2 times a quantity x minus 10. Very similar. Location's going to be different. Some things are going to be different, but it's going to be very similar. And then I'm also going to say, how about the graph of negative x plus 3 times x plus 9? Maybe I better write out that word and. Okay, that would be an excellent exercise in applying these ideas. Now, hopefully it's been driving you crazy that I did this. This is not 0, 2, this is not 0, negative 3, this is 2, 0, and negative 3, 0. Had this in my field of vision when I wrote those down, and I just wrote them carelessly. I am prone to making errors of that nature, so keep an eye on me. Okay, well, back to the thing. The axis of symmetry is halfway between these points, so what's the coordinate here? Well, halfway between x-coordinate 2 and x-coordinate negative 3, what's the x-coordinate? Halfway between the zeros, x equals 2 plus negative 3 divided by 2. Because to get the point halfway between 2 points on the x-axis, you average the 2. And you should understand very thoroughly why you do so. So that's then negative 1/2. So that the axis of symmetry is x equals negative 1/2. Well, given that here's your axis of symmetry and your 3 points here have to be on the parabola, can you sketch the parabola? You really ought to, if you haven't already sketched this out, sketch it out, or draw a new sketch if you don't want to mess up your old one, and see if you can draw a parabola that fits these 3 points. Now, I really hope that you've done that. The parabola is going to have to be of this sort of shape, because this point is lower than these two, but it's going to have its lowest point on the axis of symmetry. If its lowest point was here, Well, there has to be another point on the other side that's a reflection of this one. And if you had this point and this one, and this axis of symmetry, there's no way you could draw it so that your low point would be both here and here. Okay, so if this is your low point, then you got to have a low point over on the other side. Can't be done. So what we're going to have to do is we're going to have to deal with that by sketching the parabola, something like this. I kind of went light in here, and I kind of lost my symmetry when I did that. It needs to curve up. But we get the idea. The axis of symmetry is our low point, because there can only be one low point in a parabola. And the only place it could be is on the axis of symmetry. You want to think through exactly why that's so.